So this is a Guild annual meeting. Today is September 23rd. We're in the Concord Regional Technical Center in Concord, New Hampshire. And we're pleased to have Denab Puchalski, you get that right? From Lie-Nielsen Toolworks. Denab came down all the way from Maine this morning to give a presentation. And he's going to talk about hand tools.
All right. Thank you very much. I appreciate it. It's been kind of nice watching your how you do run business for your guild, because for Lie-Nielsen Toolworks, I travel all over the world actually, but I've gone to most of the states in the U.S. To do some similar things to what I'm going to be doing today, and we get exposure to guilds all over the country, and you guys have a very good representation, but also seems like a very unusual focus to what you do. One of the things that I noticed is the emphasis you put on education and on sharing the craft and sharing the knowledge that you all have accumulated over the years. And that, to me, is the most important thing there is. And that's what I do. People ask me all the time, what's my job at Lie-Nielsen? And my job really is as an educator. I'm there to teach people how to use these tools that we make. Because we make the finest tools in the world. And I don't have any qualms saying that. I am intimately involved in the making of these tools. I know what goes into them. I have gone and refurbished old tools like you were going to have the pleasure of doing with that little block plane. And that was how I got my start as a craftsman, because I'm a woodworker as well as a tool maker. And at the time that I started out, there wasn't really, I mean, Lie-Nielsen was around, but I didn't know about them. And so my only real option was to get old tools, tune them up, and make them work as well as I could make them work, because there weren't other options available. Now you go looking around on the internet and you're going to find a whole host of small makers that are doing everything from metal bodied tools to wooden planes and 17th century style tools. And we're in a golden age of tool making, believe it or not. People think of the teens of 1910, 1920 as the golden age of tools, but the reality is that was the golden age of mass-produced tools. The tools that you find from Stanley that were good, it was an accident, frankly. I mean, they were producing at their peak between 30 to 50,000 planes a week. It was just pure mass production to get the tools out to the world, and literally to the world. They're everywhere. And so they weren't really focusing on quality, they were focusing on quantity. When Tom Lie-Nielsen started this company in 1981, there was no option. There was nothing. He worked for a company called Garrett Wade, and he took a job with them right out of college. And he was working in sales, but it was a small company, so he did a lot of other stuff as well. And he came to recognize that while Garrett Wade focused on finding the highest quality tools available, the reality was that when it came to hand tools, there really were none. And most of you probably lived through that period of the 70s as the point of getting started in much of this stuff. So you know what I'm talking about. You know that you didn't really have any options to find good quality stuff. You had to find the oldest tools you could find and hope that they were okay and that you could learn how to tune them up and make them work. There was a gentleman named Ken Weisner who was making the number 95 edge plane. And he was basically doing that out of his garage. He was a machinist, and it was something of interest to him. He was doing the castings. He was doing all this work, and it was before the internet, so it was his only real outlet to sell these things was through this company, Garrett Wade. And he decided he didn't want to do it anymore. So it was the late 70s, early 80s, and Tom recognized that there was not just a market for that tool, which had been discontinued by Stanley back in the 30s, but for other tools like that had been discontinued, that were no longer available. And even if they were available as a new tool, newly made tool, those tools were just garbage. They were not worth the material that they were made out of, in terms of using them as for work. So he spent some time with Ken Weisner, learned some of the basics of the process, but he was not trained as a machinist. He wasn't a tool maker. He had been an English major in college. His father was a boat builder, and they not only did the woodwork for wooden boat building, but they also did a lot of the metal work as well. So there were castings and things that they made for fittings on the boats. So he'd been exposed to this stuff, but he hadn't been trained to do this work. So he had to basically, in his mid-20s, teach himself how to do all this stuff. So in 1981, he moved back up to Maine from Brooklyn, New York, and started making that one plane out of his barn. He taught himself to do the foundry work. He taught himself to be a pattern maker. He taught himself to be a machinist. And by 1987, he had moved to the building we're in now. We've expanded it quite a bit since then, but and he was only making about 4 or 5 tools at that point. We now make over 150 individual tools, and plus workbenches to work with them. And in pairing with the thing that made the mention of the education for me so poignant is that's what we've realized is the biggest thing that we have as a responsibility is to teach people how to use these tools. So we do what we call hand tool events all over the country. We've posted, as was mentioned earlier, over 60 instructional videos on our website. They're free for anybody to watch at any time. We work with the best woodworkers that we can find in any avenue of the trades, and we shoot videos with them on the different things that they do. Those are for sale, but it's information that you might not be able to just get otherwise. And in this case, you can take those, plug them in, you can download them and live stream them if that's more more appealing to you. But these things are integral parts of what we do, because if you don't know how to use these things, you might as well not even have them. Yes. No, they came together, or they came up in sort of the same time frame. What's that? If there was a connection or collaboration between John Economaki with Bridge City Tools and Lie-Nielsen Tools. And John started making tools in the same time frame, early 80s. An interesting story with that is how he came into that. And he was a furniture maker and designer. He specialized and loved working with exotic woods. And if any of you know anything about cocobolo, you know that it is what's called a trigger allergen. And what that means is that you may have had no allergic reaction to anything, and with exposure, sometimes for the first time, but usually it's with extended exposure with this material, it can all of a sudden trigger an anaphylactic reaction with any wood material that has an allergic property, even pine. So John was working on a big, massive desk project and went into anaphylactic shock, woke up in the hospital. Doctor's like, what do you do for a living? He's like, oh, I'm a woodworker. He says, not anymore. Because he ran the risk of any time he worked with any wood material that he could potentially go into anaphylactic shock and die. And we have used cocobolo for as secondary wood for some of our tools. We no longer do, because we started having people in our shop that were having minor reactions to it. It's also now on the CITES list, and it's on all sorts of other things. I mean, there are reasons not to do it that aren't directly related to the allergic properties of it, but that was a big purpose in that. And so John, overnight, had to come up with something different to do. And he recognized, just like Tom did, that there was a dearth of available things. He started out making squares. Because if a square isn't square, what do you call it? And how many squares do you have in your shop that are actually square? Very few. And so he started to recognize that, and he was making them. They're nice high-end things, and he was going around to shows and selling these things, and he was selling a square for a little, like, engineer-style square, tri-square, for $85 back in 1982 or something, like 83. And some guy walks up to him and is like, "Oh my God, how can you charge so much for a square?" And he says, basically what I just said. He says, "Well, how many squares do you have at home?" And he says, "How many of them are square?" And the guy's like, "Oh, none." And he said, "Well, how much did you spend on each one of those things that isn't square that claims to be square?" And he was well over that amount. So this stuff all has sort of evolved in a way. And John, in the early days, was focused almost exclusively on layout tools. He wasn't making planes of any kind. Tom was the one who started making planes, and he made them the way they should have been made from the very beginning. Used proper materials. Gray iron, which is what the older tools were made out of, and even some today, is very brittle and hard. It's also very cheap, or at least relatively inexpensive. So, but if you drop one, it's going to break. There's nowhere for stresses to go. They also didn't stress relieve the material properly. The way that Stanley would stress relieve castings was they would take the raw castings, make a pile out in the back lot at their factory outside, and leave them sitting for a year. That's why they call it seasoning. It would sit through the seasons. So it would sit for a year. You have no idea what happened to the tools in the middle of that pile. And remember, they're making 30 to 50,000 planes a week. So if they were starting to run short of stock, raw stock, and there was a pile sitting out there that had only been out there for 2 months, they're going to cut into it. They didn't care. That was the process. So when you use a material that hasn't been stress relieved properly, it's in a constant state of movement. So some of the old tools that you find that you will have tuned up and made nice and flat and beautiful, check them in a year. I can almost guarantee you they're going to move. They're not going to be what you did. Guess how I know that? I've done it many, many times. With the ductile iron and the manganese bronze that we use, they're what are called malleable materials. At the very beginning, Tom was using only manganese bronze because it's a material that has a relatively low melting point. So he was able to do it in his barn. He could heat this stuff to 1,700 degrees. It would go liquid. He could pour it. 2,800 degrees, almost 3,000 degrees, is a lot more heat. And that's what it's required for the iron tools. So when the first dozen tools or so that Tom was making were all in bronze. When he finally did decide to go to iron and introduce some of the bigger bench planes, he had to find somebody that could do that, do the foundry work for him. And there's this family-run small foundry in Lewiston, Maine, about an hour and a half inland from our near Augusta, if you're familiar with the state of Maine at all. And they agreed to do all his castings for him, all the iron castings for him. He did all the match plates, all the pattern work, all that stuff, and then they poured the tools for him. So we try to keep things as local as we can. Everything we make is 100% U.S. made, and that's important to us. What that really means is we went from a company where it was Tom Lie-Nielsen making one plane by himself to now we make, like I said, over 150 different tools, and we have about 100 employees, a little less. And what that means for us as a community is that's about 90 to 95 families in Mid-Coast Maine that are dependent on you guys buying tools. So you can feel good about every purchase you make. But on a real scale, I grew up in Mid-Coast Maine. When I was 17 years old, I left the state of Maine, and I swore I would never be back because there was nothing for me to do. I could be a lobsterman. I could maybe work as a contractor if there was a boom going on, which construction is boom and bust in Maine. And I could go blueberry picking. I mean, that was the extent of it. I could go work at Bath Iron Works. Well, not really. People try to farm in Maine, but it's kind of hard to get stuff to grow in rocks. So, the bigger point there is now we employ, like I said, almost 100 people, and that's 100 people who didn't have to leave. They can make a really good life for themselves in a community where that's not the norm. So it's something that we take very, very seriously, is keeping this stuff local, keeping the crafting of these tools as local as possible. It is very encouraging to me to hear the sort of emphasis that you as a group put on education and the sharing of information, because that is what is going to make the craft survive. And I think over the last 50 years, there has been a real push or movement to killing the craft, whether you want to believe it or not. The sort of Norm Abrams of the world have made it so that most likely every single one of you in this room believes at your heart that you need a production level cabinet shop in your garage to be able to make a step stool for your grandkids. Yeah, absolutely. So what that does on a real scale is it limits the opportunity for somebody to do woodworking. If you need a table saw, a joiner, a planer, a bandsaw, a set of routers, 3 or 4 random orbital sanders, a time saver sander, if you need all of this equipment to be able to manipulate a material into a shape that you want it to be, then until you've accumulated all that equipment, you can't even start. If all you have is a table saw, you can't build things. Bandsaw comes about as close as you can to sort of a tool that allows you to build off of the tool, but even that doesn't give you finished surfaces. So when you follow that logic, that you have to have this production level shop to be able to do the most simple of projects, then it pushes you down the path of machinery. And everything you learn with machinery, none of it translates over to hand tool work. But everything you learn with hand tools translates over to machine work. So in the early days of things, all there were hand tools. And so as machines started getting added into the sort of working experience, you still, as an apprentice or as at the early stages of learning how to work with wood, be a carpenter or a joiner or whatever you were going to be doing, building, whatever it might be, you had to master hand tools before you could move on to machinery. That's no longer the path for most people. Most people now jump right into machines, and you're very limited in what you can do. You need whole books of measured prints and drawings to be able to build that birdhouse you're just dying to have out in your backyard. You need these things that everything, if you don't put very precise, accurate numbers into a machine, you don't get results back. But that's not how people build things. That's not how people make things. It's not how you design. You design with proportion. You design with what looks and feels good. And working with hand tools encourages that behavior. If you're going to work with hand tools, you have to learn how to work with wood or whatever material you're working with. When you're working with machines, you're imposing your will upon a material. And wood is a very fickle thing. If it doesn't want to be something, it's not going to stay there. It's not going to remain what you created. If you make a beautiful tabletop with 5 different colors of wood, and you put a nice tightly mitered apron rim around the entire thing, it will maybe be 3 weeks before the whole thing blows apart. Because that solid wood is going to move. You can't stop it. They used to calve off chunks of granite in quarries by drilling holes, putting wooden pegs in, and pouring water. Let that wooden peg expand, and this 15-ton chunk of rock comes falling off a cliffside. So you can't stop wood movement. If you're working with machines, you can ignore it at your peril, but you don't find that out until later. When you're working with hand tools, you have to work with that material. You'll find out really quickly that things won't go well if you don't do it appropriate to the material. A lot of the techniques that you learn for putting things together, for assembling pieces, come from not the experience of somebody making all this stuff with machines, but from people having built it that way with hand tools and then applying machinery to the task. So if you don't get that understanding and that knowledge at the beginning of things, then it becomes much more difficult to really master what you're doing. You don't necessarily understand what you're doing. And none of what I'm saying is saying that you shouldn't use machines in your work. We use CNC equipment for a lot of what we do for making these tools. But every single tool we make has some element of handwork involved in it. Hand machining. We file certain areas where we could let a round corner go, but that's not what it's supposed to be. It's supposed to be a square, clean corner. So we go in there with a file and hand work that surface so it looks better. It looks appropriate to what it's supposed to be. The surfaces of all the handles are hand sanded. So you can line up 10 of the same plane on a bench. No 2 of them are going to feel exactly the same. The base handle came off of a CNC mill, but all the hard edges are taken away by hand, by a person. So when you pick up one of our tools, I firmly believe this, and I've thought this since long before I worked for Lie-Nielsen, you feel a piece of the maker in every tool because people worked on these things. We use machines to do it, but it's a very real thing. You take a table that you can buy a table at IKEA. If you take that same table, give it to a furniture maker, have them reproduce that table identically. Put those two things in a room, and everyone who walks in that room can tell you which one was made by hand and which one came from the store. Not just because of the label that's stuck on it. You just feel it. There's something that's very real. And the more that you do by hand, the more that connection is there to things. One of the biggest things to me, or the biggest message I hope to get across, and this is something that I feel groups like yourselves can really help with, is getting across the idea of how important it is to learn how to use these things. Because they open up doorways that you may otherwise be closed. You can buy, this is what I have here, the stuff on this side are some extras, sort of things you may end up getting over time, but you don't need from the very beginning. But what I've got in front of me is what we consider the core tools, the tools that you need to be able to build things. One thing I'm missing is chisels that I forgot to grab this morning at 5 o'clock when I was running out the door, but I apologize for that. But what you have here are the tools required to turn material from rough lumber to a finished piece of furniture. You're taking one of three cuts with any plane. You're either taking a roughing cut, a flattening cut, or a finishing cut. And that's just how thick of a shaving you're taking. The heavier, thicker shavings are your roughing cuts, and the jack plane, which is a medium length tool, is the most suited to that tool. Whether this is a low angle or a traditional plane, that's immaterial in terms of the classifications of these things. But that jack plane is long enough to get something reasonably flat, but it's short enough to get there quickly. The proportions are such that where the mouth opening is, it's a little closer to the front of the plane than it is to the middle of the plane. When you're working with the flattening tool or the joiner, that mouth opening is closer to the center of the tool than it is to the front. So you have more bearing surface in front. This tool is going to force a piece of wood to become flat, whether it's 8 inches long or 8 feet long. It doesn't really matter. This plane will get that board flatter than that plane will, simply because of the bearing surface and proportional actions of that tool. The smoother doesn't cut more smoothly than the other planes. You can set any one of these three planes up for the same cuts. It will take the same thing. This one's smaller, so it'll allow you to take those really, really thin finishing passes more quickly, faster than you would be able to take with any of the bigger planes. If you only have one of these tools, you can set it up for all three of those cuts: roughing, flattening, and finishing. But every time you back up the cut to take the next in series, you're going to find that you don't get a cut right away because you haven't changed the bearing surface. You haven't changed how the tool is interacting with the material that you just cut. So it becomes much more efficient to use the three together than to use any one of them as the only tool you're going to use for the process. Some things you do don't have to go all the way to the final finishing stage. Interior surfaces where things are joining together, those need to be flat where the joint is happening, but they don't necessarily have to be a perfect, smooth, glassy finish. It might be that way because that's what planes create if they're sharp, but it doesn't have to be. The outer surfaces, the show surfaces, don't necessarily have to be as flat. So you may eliminate some of the other steps or not go quite as far with the flattening stage as you will on the inside surfaces. So you're making these choices and decisions as you're working stuff through. You don't have to work to specific dimensions. As long as things that interact with each other are the same thickness, it doesn't matter if every single piece that you work with is uniformly the same thickness. In fact, usually things look better when there's subtle variations in that stuff. as long as the areas that need to be coplanar with each other are. So it gives you a lot more freedom to work. I think one of the most surprising things for people when they start focusing on handwork and working with appropriate tools for the appropriate jobs is how fast it is to do things by hand. Everybody has this assumption that machine work is fast and handwork is slow. But everything that was built in this country before World War II was built by hand. Bridges, skyscrapers, wharves, ships, everything was built by hand. Those people were not slow. Where I live in Waldoboro, Maine, is the home of the five-masted schooner. It's about a 360-foot long vessel. They were built from, I think it was 1895 to 1914. It's when they were building these ships. They built 7 of them in 5 years. So every 9 months, they were launching one of these things, ready to go. So it's not slow stuff, but there's become this sort of connection between speed with machines. It's slow and sort of romantic to work with hand tools. If you're doing one-off stuff, it's faster to do it by hand. The only place where you're going to see a speed advantage is in the rough prep of stock. And you can buy pre-dimensioned stock if that's really an issue for you. But also realize that it might take you a couple days to get your stock all prepped by hand. It's not that much longer than it's going to take you with machines. And if all you're doing is the material for a project, a single project, it's a couple days. It's not a big issue. If you have the machines available to you, use them. I would encourage you to use them. But don't let yourself be stopped from even starting because you don't have the machines. I was started out as a boat builder and did house carpentry. It was around 1995 to 97, I decided I wanted to just sort of expand on my joinery skills. So I went to a school up in Maine called the Center for Furniture Craftsmanship. And it was a 12-week program. And I learned a lot of these sort of things. When I came out of that, my goal was to start a furniture shop. I started ticking off all the machines I needed to buy to set up my shop. And I was got pretty quickly to about a $20,000 to $30,000 investment just on the equipment that I wanted to put into this shop that I was going to then use to build furniture. And soon after that is when I started working for Lie-Nielsen Toolworks. Because I made a decision of, rather than starving myself as a furniture maker, I was going to make tools to make those things and teach people how to use those tools. But the biggest thing that stopped me was that thought of, I just don't have the money to have all this equipment. If instead I had taken the hand tools that I already owned and just started making stuff, I'd be a furniture maker today. So this core grouping is the jack plane, the joiner, and the smoother for the dimensioning and surfacing of material. You've got, for joinery and detail work, a block plane, a shoulder plane, which has the blade running out to the edges, a router plane for bringing things to a specific depth. This is a tongue and groove plane, but it's a version of a plow plane. It allows you to cut grooves in surfaces. This will be a fixed dimensional groove. A true plow plane has an adjustable fence, so you can position it differently and you can add different widths of blade. And we will have one of those out very, very soon. We're hoping to have it out possibly even by Christmas, but I wouldn't hold your breath. It's been several years that we've thought that. So, to separate things from themselves, you need saws. A carcass saw is a crosscut saw. The teeth are filed at a slight angle. I've got two rip saws. One is the dovetail saw, which is a finely toothed, small-scale saw. The other is a tenon saw, which is just a coarser toothed rip saw again, much larger in size because tenons tend to be rather deep. It's longer because they're usually a longer cut. The coarser toothing is because you're removing more material than you do with a dovetail. So those three saws will allow you to do the majority of that sort of joinery around the bench. One saw that I didn't bring with me is a panel saw, or a traditional hand saw with no back. If you're not going to have a table saw or a band saw or a chop saw, you better have a couple of hand saws. At the very least, get a rip hand saw, because a rip saw will crosscut better than a crosscut saw will rip. So again, if you can only have one, go with the rip. The one thing that I didn't bring that falls into that joinery and detail area is chisels. You don't need 45 chisels. You need the sizes that you need. They're a little bit like clamps. It's hard to have too many because it seems like whatever size you don't have is the one you need at the moment. But if you have at least a 3/4 inch, a 1/2 inch, and a 1/4 inch bevel edge chisel, you can do a lot of different things. If you're going to be doing mortise and tenon by hand, get a 1/4 inch and a 3/8 mortise chisel. Fishtail chisels are nice for doing some detail stuff, but at the bare minimum, those 3 bevel edge chisels will do most of what you need to do. You can always get other sizes as they come necessary, but you don't have to have all that stuff. That grouping of tools that I just mentioned, so it's about 7 planes, maybe 5 or 6 chisels, 3 or 4 saws. If you buy all our stuff brand new, it's going to cost you between $2,500 to $3,000. That includes the sharpening equipment to keep them working, functioning. That's about the cost of one good quality piece of power tool equipment. So a table saw, a jointer, a planer, the bandsaw, all the hand power tools that you need to do what these tools allow you to do. That's another $2,500 to $3,000. So if you're trying to get started in the craft or trying to better to gain a better skill set in making things by hand, get that grouping of hand tools and master those hand tools, and then it'll make everything else you do better. I don't care if you buy all our tools or not. What I care about is that you have that association of them. Because if you're missing any one of those tools, you're going to have to make something else reach to do it. I've got some other tools over here that still fall within that sort of core grouping, but you don't have to start with them. When I'm doing roughing, bringing a rough board down to something to work with, I will start with what's called a scrub plane. Very narrow, small plane. You can take a really heavy, aggressive cut, but it tears out badly most of the time. So it's not for flattening, it's for removing stock, just getting rid of material. This is replacing a hatchet, basically. It's a more controlled hatchet. Fantastic thing for just removing stock. But to clean up the mess that I make from that, I want to have a jack plane. I put what's called a tooth blade in this low angle jack plane because I can take really heavy aggressive cuts without worrying about tear out. So I can clean up the mess I made with my scrub with the tooth blade here. I can then switch over to a regular blade in this, or personally, I love the 5.5, the weight, the feel of it. So I have all 3 of these planes that I use in my roughing stage. And what it means is I get stuff roughed down to my base level of stock removal really, really fast. Because I'm not worrying about tear out with this one. I'm just getting rid of stock. I clean up any heavy tear out that I got with the tooth blade, and then I clean up the toothing marks with this one. Then when I'm ready to do the flattening of the stock, get rid of twist, get rid of any little cup, any crown in the board, that's when I turn to the joiner. And get it as flat as you need it, thin the smoother if you need to. Yes?
The bulk of it down?
It depends. I would prefer to cut at a 45-degree angle across the stock because you're flattening in the width and the length at the same time. But if you're getting a lot of tear out and you don't have that tooth blade as an option, go 90 degrees across. It's called traversing, because you're, rather than biting in and lifting along the length of the grain, you're going straight across the grain, and it doesn't separate as much. You don't get as much tear out. You'll see a very, very distinct difference between a long grain cut shaving and a cross grain shaving. And as soon as you see it, you understand why tear out doesn't carry. It won't be a smooth surface, but it won't be a big mess to clean up either. As you start working this way, you start to realize there are a lot of places where the machine options actually get in the way and limit what you're able to do. You are much more in control of what you're doing when you're working with hand tools. The thing that I think scares most people away from hand tools is the idea that that it's a difficult skill to learn. And there's things that come with experience that you just can't, you can't replace experience. I've been working with hand tools for almost 40 years. Every time I push a plane across a board, I learn something new. So it never stops. It's a constant thing. But there are really only two skills that you need to learn to have success with hand tools. You need to learn how to sharpen, because dull tools don't work. It's not that they don't work well, it's that they don't work, period. This $475 plane is just a big doorstop if the blade's not sharp. So you have to learn how to sharpen, and you have to learn how to set tools up. Once you have control over those two things, you can use any hand plane you pick up, because the principles are the same, pretty much the same. You decide on what type of cut you're wanting to take with that tool, you set it up to take that cut, and if you don't get the results you're looking for, you know where to go next, what tool to reach for to get a better result. The thing about sharpening, to me, is that for most people it's an obstacle. It should be the gateway. So we've spent a tremendous amount of time, myself particularly, on coming up with a method that makes it so anyone can get great results the first time and every time they sharpen. And to me, that means sharpening with a honing guide. And there's a certain mentality within woodworkers that freehand sharpening makes you a better woodworker. Freehand sharpening doesn't make you a better woodworker. Sharp tools make you a better woodworker. And I can almost guarantee you that if you do not spend the next 300 hours of your life trying to learn how to freehand sharpen, you will not get good results. You might occasionally get a really good edge, but more often than not, you're going to get a somewhat passable edge. I can spend 10 minutes with you and teach you how to freehand sharpen. I can spend the same 10 minutes, teach you how to sharpen with the honing guide and this other stuff. If I show you this way, you're going to go home and get results. You're going to get the same results you see me get. If I show you how to freehand sharpen, you're going to go home and curse my name for the next 2 years, if you even persevere to try to keep working with these tools, because the results are not going to be good. You're not going to have success. So there's no shame in using a honing guide. Honing guides have been around for as long as people have been trying to put edges on steel. Just different versions of it. We spent almost 8 years working on this honing guide so that it would be what it needs to be to work, to function. It's based off of the Eclipse style side clamping honing guide, but it's very, very different. It's all stainless steel for one thing, rather than being aluminum. But more importantly, the blade is registering in here off of the back of the blade, the upper surface. Most honing guides register off of the bottom surface. So if your thickness of blade is different, the angle that you're going to get is going to be different with an equal projection off the front of the blade. With this style, you can set up these little stops I've got here. Go to the angle you want to sharpen at. Every time you go to that same stop, you get the same projection, you get the same angle. So it's fast. There's no guesswork in trying to get it to work. Thing to understand about a sharp edge is the sharp edge is simply the intersection of two evenly polished surfaces. Once you have that, and I can do that on the concrete floor, as long as those two surfaces intersect together and they're polished to the same level, I'm going to have an edge that can cut. So I go to a 10,000 grit finishing stone, my final grit. I don't have to, but it takes me about 30 seconds to put an edge on a blade. So why not put as fine an edge as I can put on there? This 10,000 grit stone is the equivalent of a strop. So if you use oil stones or you use diamond plates for sharpening, you're going to find that you need to strop to get that final little edge, the last bit that you want for the best results. Going off the stone with the honing guide gives me a controlled angle on the surface. I'm not hoping that I don't dub it off or round it too much with a strop. So this is all just about consistency. Consistency is the key to success when it comes to sharpening. If you get consistent, repeatable results, it's fast and it's predictable. You know what you're going to get every single time you do it. So working with flat stones is the other part that's important. You can get your blades sharp with stones that aren't flat, but you don't know what the shape of that blade's going to be. So if you sharpen or flatten your stones regularly, after every 20 or 30 passes on the stone, you should probably reflatten. If you're using the honing guide, you're only working off of half of a stone. So I'll sharpen one blade. It's usually no more than about 10 strokes. Spin the stone around, do another blade, spin it around, I can do another blade, spin it around, I can do another blade. Usually I'm only sharpening one blade though. I try to sharpen my blades as they need it rather than waiting till I've got 20 of them that are all dull and need to be touched up. So if I'm going to sharpen 4 blades, I'll wait and flatten after the 4 blades. But if I've only sharpened one blade and I'm going off to do something else, I'm going to flatten my stones, because then I know what I'm coming back to the next time around. So again, the process, simply go to whatever angle you want. I typically sharpen it with a 35-degree secondary bevel so that I don't have to, I'm not having to polish all of the primary bevel. It's a lot more material. It takes longer to do. You also spend more time on the stone. With any abrasive, the less time you spend on the abrasive, the less likely you are to shape it in a way that you don't want to. So if I can get away with 3 or 4 strokes on my stone, great. A trick to this is stop when you're done. So give yourself indicators of when you're done, when a step is complete. So my first indicator here is this 1,000 grit roughing stone, I call it. And as soon as I can feel a burr or a wire edge on the back of my blade, then I know I've achieved my intersection. Then I want to polish it. Off this 1,000 grit stone, I'm going to get a polished surface, but it's going to be a dull gray color. When I come off this 10,000 grit finishing stone, it transforms to this bright, almost black polish across the whole thing. As long as I felt the burr first along the whole edge, and then I see the color change along the whole bevel side, that's it. I don't even have to check it. I know it's going to be sharp. And it's going to be sharp every time I repeat those stages. The longer you wait between sharpening, the more exaggerated what's called a wear bevel develops. That wear bevel is an interference to success, because what it means is you don't generate the intersection of the back and the bevel. That applies to anything you're trying to sharpen. It's a pocket knife, it's kitchen knives, it's chisels, it's plane irons, it's carving tools, whatever it is. If you don't generate that intersection of the two surfaces, it will not cut the way you are expecting it to cut. So I go to my 35 degrees stop. I work about 4 or 5 strokes, and I'm going to check for a burr. If I can feel the burr, I stop and move on. If I don't feel it, I'll do another 4 or 5 strokes. I do this little short bursts like that so that I don't go too far. As soon as I feel a burr that wasn't there before, I know I'm ready to move on to the next step. I always wipe off the little wheel and the blade so I don't transfer the grit over. And as long as you have a puddle on the surface of a water stone, it's ready to use. Some require a lot more water than others. These particular ones, just that little spritz of water isn't enough to build a puddle, so I don't need to soak them. If you can't get a puddle to stay, soak them in water for a little while. Some of them, you have to leave in water all the time. They get really soft, and they're not useless, but damn near, because they gouge easily. When you do flatten them, you take off, you just get this mud puddle all over your bench. So when I look at that bevel, and probably can't see it, but it's a dull gray color. It's a nice straight, even line across the cutting edge. I hit it on the finish stone. Same 4, maybe 5 strokes. And I'm going to look to see whether the polish changed. You can see that flash. At first, it was just a dull gray color, more closer to the color of the guide itself. Primary bevel on most plane irons is 25 degrees. I chose 35 degrees for the secondary bevel because it gives me 10 degrees of difference between those two angles, so my secondary bevel will grow really slowly. The closer those two angles are together, the faster the expansion of the secondary bevel becomes, and that just means you have to grind more often. I freely admit that I hate sharpening. I have to sharpen to get good results from my tools. I despise grinding because it's just a complete and utter waste of my time. So if I don't have to grind something, I don't. So if I can get an extra 10 or 15 sharpenings by going an extra 5 degrees on my secondary bevel, then I'm going to do that. The limiting factor, and the reason I use 35 degrees, is that when you've got a blade sitting with the bevel down, like is in the traditional tools, you need to have a minimum of 10 degrees of relief to the heel, from the heel of the bevel to the workpiece underneath. So if there's not a 10-degree relief point there, as you cut the wood, the fibers are compressed. those wood fibers spring back up as the blade passes by. They'll spring up enough, if there's less than 10 degrees, it'll just push the tool right out of the cut. And if you match the bedding angle, just glides right across. And any little high points, you might scrape the material away, but you're not cutting down into it because you've got this little skate there that's keeping the blade from engaging into the stock. So that 35 degrees. The primary bevel, which is the angle that's cut, is 25 degrees most of the time. There's some instances where that angle might be different, but for most things you sharpen, the primary bevel is going to be 25 degrees. By going to 35 degrees, I've got 3 or 4 times more time before I have to regrind to shrink that down again to be a small polished surface. In the traditional bevel down planes, if I've got a 45 degree frog and I've got a 35 degree secondary bevel, I've still got 10 degrees of clearance to the workpiece underneath. Yeah, absolutely. There's all kinds of studies, and you can look under microscopes and see all kinds of crazy stuff. What you will find is that this 10,000 finish is about as far as you need to go. A strop is about as far as you need to go for a polish. You won't, in use, be able to tell the difference between a 10,000 grit finish and a 30,000 grit finish. When it comes to the angles, if you're talking about a chisel, if it's a standard bench chisel that you're going to be chopping with or paring with, 35 degrees is about as steep as you want to go for the angle because it starts to not be as effective for paring. But if you use 20 degrees or less, you're going to find that it doesn't work very well for chopping. 30 degrees is a great angle for 30 to 35 degrees is a great angle for chopping chisels and still being able to pare. So that 35 degree angle starts to carry through into all these different applications. It will hold up a little bit better, a little bit longer than a 20 or 25 degree will. But if it gets too blunt, then it starts to dull more quickly. What you'll notice with a really low, shallow angle tool is that even as it breaks down and dulls, there's less material behind it, so it stays more keen for a little bit longer period of time. So a really shallow angle in, say, 01 steel, and I'm about to get probably way more technical than anybody wants to hear, but 01 steel is something that people feel they can get a keener edge in. The way that the grain structure forms, you can grind it to a keener point in some cases than some other materials. So it's used for very fine cutting edges. So a paring chisel, you might grind the bevel down to 15 degrees. As you're working with it, it's going to break down much more quickly than a steeper angle will, but it's going to maintain the ability to cut for a longer period of time as it breaks down. The steeper the angle becomes, as soon as you get rid of that crisp intersection, it becomes dull almost immediately, where it just won't cut the way you expect it to. So A2 steel, which is what we use, holds its edge for a longer period of time. So it allows you to work at steeper angles, which give more support to the edge because it won't break down as fast at the absolute edge. And we heat treat our A2 steel in a way that means that the crystalline structure of that steel is refined to a point that you can grind these or sharpen the RA2 steel to as keen an edge as you can the high carbon steels that people prefer. Yes. Have you ever investigated wanting to pay $300 for a blade? We've looked at it, yes, and sintered metals and all that kind of stuff. And this is a $324. Well, this one isn't, but the 4.5 is a $325 plane. We would have to charge probably about $300 for the blade alone for this plane in that type of material. So you would have a $600 plane instead of a $325 plane. Good question. Those are, they end up being all kinds of different materials. There's typically a fairly high carbon, but it's most often it's what's called sintered metal, which is a powdered form that becomes recompressed into a solid, and it's just really expensive. It's really hard to sharpen as well. They hold edges for an incredibly long time, but it's not, the balancing point is, it's a diminishing return. That is everything. So if people claim that an 01 or a high carbon steel blade is easier to sharpen than an A2 blade, and the A2 does need to be treated properly, it needs to be heat treated properly. But if somebody claims that one is easier to sharpen than the other, almost 99% of the time, if you do a Rockwell hardness test, you're going to find that the one that was easier to sharpen is softer. And one of the reasons we prefer the A2 steel to the 01 or high carbon steel is those are liquid quenched. The A2 is air quenched, meaning that the entire length of this blade is the same hardness throughout. When you liquid quench, you only dip a portion of the blade in, and there can be a lot of variance from one blade to another. So if we do a batch of 500 blades, heat treat a batch of 500 blades, there's a very, very high chance that some percentage of those blades are not going to be within the 60 to 62 Rockwell range that we're looking for hardness. The temperature will vary. Yep. Exactly. So there's more potential variability within that type of quenching process. So we just get a more consistent result, and then you get the added benefit of a little more edge life or edge retention in the A2. So that's why we use A2 steel. What's that? The A2, it doesn't perform well. It's not that it's designed to be quenched in air. Essentially, they heat it in a vacuum, and then when they release the vacuum, that's the quench. So it's instantaneous throughout the entire piece. Yes. Mm-hmm. That is a right. 01 is a water quenched high carbon steel, or an oil quenched high carbon steel. W1 is a water quenched high carbon steel. A2 is an air quenched it's got different alloys in it. It's got chromium, and it does have carbon. It has regular steel. But there's a chromium mix in there as well. Again, that's getting way too technical, I think, for what we're trying to talk about. So my process here was set the angle, work till you get a burr, polish till you see the shine all the way across, and then rather than lapping the whole back of this blade, which I've lost well over a month of my life, I'm never getting back, dressing the backs of blades. And it does no purpose. What matters is that the blade is polished out at the cutting edge, at the tip, not that it's polished back here. This is never going to see wood, never going to cut anything. It has to be polished at to the same level as the tip. A gentleman named David Charlesworth came up with something that he calls the ruler trick, which is essentially a controlled stropping. If you strop, you introduce a back bevel because it's going to ripple. It's going to roll away and it's going to round off the back side of the blade. What I'm doing here is I stay as far away from this little ruler as I can. I've got the ruler on one side of the stone. I stay within a half an inch of the other side of the stone and just run back and forth along that edge. The first time you do that, it might take 10 or 12 strokes to be able to see the polish go corner to corner on the back. As soon as you get, where'd it go? Is that? There you go. You can see the polish at the very, very tip. It's small. It's half a degree or less. Okay. It's about 20 thousandths thick. So it's very, very thin. This will introduce about a half a thousandth or a half a degree or less back bevel. Yep. Once that's done, you wipe it down, back to work. So if I'm not going on and on about this, it's about 30 seconds at the stones. Yes. Possibly a little. Not enough to worry about it. No. That's one of the reasons I stop as soon as I feel a burr. The heavier the burr is, the more it's going to go back and forth. So when I first take a blade out of a tool, I'm going to check to see if I can feel any damage from the use that I've been doing, where I might think that I feel a burr. If I do, I'll do the ruler trick before I sharpen. But I always finish with the ruler trick. I only start with it if it's either a blade I've never sharpened before and I need to introduce the polish, or if I can feel a little bit of a burr before I've started to sharpen. Because then if I do 3 or 4 strokes and I feel even the trace of anything there, I know I've generated my intersection so I can move on. If I'm not positive, I think I might need a little bit more. I just do a couple more strokes and check again. Because the more you do, the more likely you are to negatively affect the blade. Yeah. So if I've got a blade that is new to me, never sharpened. No, I go straight to my finish stone. I prefer the 10,000 grit for the finishing stone. You can use an 8,000, but you may find you want to strop after working on a 8,000 grit stone. So assuming this is a brand new blade, one I've never touched, I come to the stone, my finished stone. First, I'm going to make sure it's flat. I drop this ruler down. I go to this opposite side, no more than half an inch onto that edge. The closer you get to the ruler, the steeper the angle becomes. So I want to stay over towards that edge. I do maybe 10, 15 passes back and forth and check to see what I've got. If that polish goes corner to corner, you're done. Move on. 10 seconds. I'll talk about that in a minute. So once I get the polish that I'm looking for, that's my prep for the back of the blade. I don't do this on chisels because chisels need to be used for paring, so you don't want that little back bevel at the tip. But this is how I treat all my plane irons. So I've got the polish that I want on the back. I decide what angle I'm going to sharpen the blade at. I'm not going to do the 25-degree primary. Typically, I do 35 degrees. So I've got my stop set for 35. I come here, and I do 4 or 5 strokes, and if I can feel anything, then I move on. If I'm not sure, I'll do another 4 or 5 strokes. I can feel a little bit where I wasn't there before, so I move on to the other one, the finish stone. You may pick this up this time. Let's see, it's kind of dull gray there right now, along the edge. And now it just pops. Yeah. There you go. It's just like a mirror. So if you see that corner to corner, now you're done with the sharpening process. Yes. No. If you use oil stones, Arkansas stones, the finest translucent Arkansas or a black Arkansas, it's about the equivalent of a 4,000 to 6,000 grit water stone. So this is a 10,000 grit water stone. The last step then is simply the ruler trick. 10,000. I've got a 1,000 for the roughing stone to pull the burr. I've got a 10,000 for the finish. Yep. No, these are Ohishi stones. The difference between the Ohishis and the Shaptons, they both don't require soaking. But these have a clay matrix. The binder that holds everything together is clay, whereas the Shaptons are a polymer resin matrix. So these ones, there's feedback. You feel the cut. With the Shaptons, you can see that it's removing material, but you don't really feel it. It just kind of glides over the surface. So I prefer these. If you use the Shapton Professional series, they're just like these. In terms of thickness. The glass back, there's no difference in terms of the cutting action, but the glass ones cost the same as these do. They cost the same as the Professional series, and you get a third of the thickness of material. So I prefer these stones because I like the feel of the blade running across the stone. I think they might cut a little faster. They're pretty close in terms of performance and everything, but you get 3 times the thickness for the same money. Mm-hmm.
I know it's like some stones polish better.
Mm-hmm.
I mean,
Yep.
You can have two 10,000s and 2 8s, but yet one will do a better job of like polish. It doesn't mean the other one isn't sharp.
Right.
It's sharp. It just don't have that mirror.
Mm-hmm.
Is that correct?
Yeah, I mean, it's a lot of that's the binding agent. That's because it all is part of the cutting action, and so it depends on what's there. I mean, you're not going to find much better than what I just put on there. And yeah.
Just wanted to clarify. If you, I know you don't have the chisels. If you're going to sharpen the chisel,
Yes.
you do the back first.
Yep.
Without the ruler.
Yep.
And then you do your 1,000. And then go back to the 10,000.
Yes. Now, if I have a chisel, again, it's new to me, first thing I do is go to this 10,000 grit finishing stone. Does anybody have a chisel here with them? Yeah, no. That's a funny guy. So to flatten these stones, I use this DMT dia flat lapping plate, and that's an important distinction because they have another one they call a dia sharp. You can get, this is 120 microns, so it's very coarse. It knocks the stuff down fast. the dia sharp doesn't have the protective coating that the dia flat has. So the grit from the stones will get between the diamonds, and the diamonds will pop off of the plate. And that happens on most diamond plates. The dia flat has a protective coating that keeps that from happening. So not only, if those diamonds come off, not only do you no longer have the abrasive quality of the plate, but the diamonds have bedded themselves in your stones. So you're going to get a poor quality sharpening. To keep them flat, I simply come over here, dress the surface, and I always spin it around about halfway through so that I don't taper my stones. Whatever I did from the one direction, I do from the other. What's that? No, it's a 120 micron, which is about the equivalent of 120 grit sandpaper. Works fine. If you put it on a granite block, that's fine. I would use no finer than 150 grit. The problem with sandpaper is it's not convenient. This is just, I've got three things. This is never going to wear out. If you never, as long as you never do a blade on here, hardened blades will knock the points off the diamonds. If you're using the non-coated one, the diamonds will come off. If you're using this diamond plate to flatten your stones, whether they're oil or water stones, doesn't matter. As long as you're doing that, you'll never wear this stone out. So it's just convenient. You can use wet dry sandpaper. If you're going to use sandpaper, I'd actually recommend drywall screen, because it gives somewhere for the slurry to go, and it'll leave some grooves in your stones, but it doesn't matter. The grooves won't hurt a thing. Yeah. Well, this has the plate, the coating on it, so the diamonds are there. The diamonds stayed there. They didn't come over here. Yes, but it's different. It's a silica carbide, so those aren't hard enough to bed themselves in the stones. They're too similar to each other. The diamonds are hard enough that they're looking for something to bed themselves into. The stones are the softest thing around, so they will go into that. Not all of them, but enough that it's going to cause problems for what you're doing. So if I have a chisel that I want to sharpen, I never go along the length of the stone like this. If you go back and forth here, you're going to start dishing the stone, and you round the back of the chisel. If you go at a diagonal, you're going to round off the corners of the blade. So you end up making more work for yourself. Once you create a crown in something, it's almost impossible to get rid of with the means that you have at your disposal. I rarely use coarse grit stones because they dish too quickly and they start to shape things. I don't want to have to use 15 different grits to go through my process, so I don't use the coarser ones. I'll divide this stone into thirds, and I start by working in the first third, just stepping as tight as I can, maybe 1/8 of an inch step, go down and back the length of that stone. Then go 2/3 of the way, down and back, then go all the way across, down and back. Take a look. Do this on the finished stone. Take a look at the back. If you see a polish up here, and a little bit of polish at the back, and some traces through the middle, stop. If it's polished evenly all the way across, stop. If it's crowned and you're not hitting the cutting area, you've got some work to do. I would take a relatively narrow strip of sandpaper and work back and forth across that paper in the middle area, and then do what I just did again. And you'll find that you contact the front and the back, you've created a little hollow in the middle. Anytime you're trying to get something flat, start from a hollow. If you start from a crown, you just reproduce the crown. You'll never get rid of it. When we make our chisels, we actually introduce a cup of like 2/10. It's not, almost nothing, but it's there so that when you work on your stones, you're contacting the working areas of the blade rather than not. Yeah. So less, way less than 1,000th. Yeah, there you go, whatever. I'm not an engineer. What's that? Yeah, it doesn't hurt. Doesn't hurt, but you'll see the polish right away. It pops right out. You'll see where you're working. So anytime I have a blade or a tool that I've never worked with, that I don't know what it's going to be, I start out on my finished stone. I want to see what I've got. What am I working with? If I don't have to do any extra work, hallelujah. I don't have to go back and do anything else. But if I start on my coarse grit stuff, I guarantee that I'm going to have to do a lot more work because I'm going to overshape the surface, and then I've got to get back to where I might have already been at the very beginning. So when it comes to the ruler trick, no, because you want to be able to pair with a chisel. You need to be able to use the back as a reference. Even the half a thou or half a degree back bevel is going to mean that I have to hike the blade up to get it to cut in. If it's a blade that a chisel I'm never going to use for pairing, if it's only going to be used for chopping, I'll do the ruler trick on the back of it. Sometimes a back bevel on a carving chisel is actually not a bad thing, because if most carving tools have double bevels, even if it's very, very slight, because you end up stropping and you round everything off anyway. So you don't want an exaggerated double bevel, but you've got the shaped bevel, whether it's the outside or inside curve, and then you're working the opposite side has a little bit of a back bevel return. For plane irons and chisels, yes. For carving tools, you can't use the honing guide. Yeah, the same principles apply. Absolutely. Well, with carving tools, if you strop before it gets dull, before you need it, if you strop, you rarely have to go back and resharpen. It's only when you start to reshape the bevel that you need to go back and rework the edges. So you shouldn't need to go to stones very often with your carving tools, only when you damage them. So the other thing you have to master is setup. And I use this little block of wood to do that. If I take a shaving from each corner of a blade, then I can see exactly what that tool's going to do. Take one cut from one side. Never used to need this step, but right? And Father Time is the only undefeated person on the planet. So by taking a cut from both sides, where is that? So you can see that I've got a shaving from each corner of the blade. One's thinner than the other. So I know that it's not set parallel to the sole of the plane. If you press the lateral adjuster towards the heavier cut, then you got take that same shaving. I prefer doing this braced up against something, so I'm working actually pressure down, but you can do it in your hand like this. The heavier the cut is, the harder it is to tell what's going on. So I'm going to back off to take the thinnest possible cut. And then by using this at about 1/2 inch thick and about 2 inches long, I'm isolating the area around the blade. So I know exactly what this tool will do when it touches the wood. So I'm setting it up for parallel, but also for a thickness of cut. I'm taking either the roughing, flattening, or finishing cuts. So a really heavy, aggressive cut, about maybe 4 to 10 thousandths of an inch thick in thickness. A piece of paper is about 4 thousandths thick. So I'm taking anywhere from 1 to 3 pieces of paper for my roughing passes, typically with the jack plane. When I'm switching to the joiner plane or the flattening tool, I'm going to be taking about half what I did for the roughing stage. So I'm going to be between 2 to 4 thousandths thick. So half a piece of paper to a piece of paper. That's going to be, that 4 thousandths cut is going to be a pretty heavy flattening cut. I'm not going to have a lot of control. I'm not going to really be introducing flat as much as if I back down a little more. So I tend to work to the finer cuts. Most people work to the heavier cuts because their blades aren't sharp. When a blade isn't sharp, it doesn't cut properly. It doesn't allow you to take the shavings that it should take. So I'm setting up, wow. I'm setting up based on what I want that tool to do as an end result. My first step is make sure it's parallel, then come down to whatever depth it is that I want that tool to be working at. So I've set my tools up for what I want them to do before I ever approach the wood. And if I take a pass and I don't get a cut, I know it's the wood. It's not the tool. I know where the problem is. And I can start analyzing what's happening. I can determine where I need to remove more material. So it gives you control rather than just reacting to what you see. So once you've mastered those two things, the sharpening of the blades and the setup of the tools, then it opens up the doorway to what these tools can actually accomplish. And if you start out with the focus, if you want to be building things, if you're not doing production work, but even if you are doing production work, it still is beneficial to get a real fluency with hand tools. But if you're not doing production work, I would say you're doing yourself a disservice by ignoring hand tools. Because you'll find that most of what you do is going to be faster, easier, and give you better results with hand tools than it will with machines at a quarter of the cost. And that's if you buy all our stuff brand new. You can go a hell of a lot cheaper too if you get stuff that you're willing to work on and tune up and make work. You have a question?
On the plane, for rabbits, rabbit.
The shoulder?
No, the
Oh, the router plane.
How would you sharpen that?
I let it hang over the edge. I basically treat the bevel as if it's the back of a chisel. In that I'm going to pop, because that's the part, I don't want to have to mess with that. Because if I start grinding on there, I'm going to change shapes, I'm going to mess with things. So my very first thing I'm going to do with this is hit it on the finish stone, hanging over the edge there, and just see what I've got. If I can get a good polish right away, great. If not, I go down a little coarser, work it in. As soon as I get a burr coming up on the backside, on the bottom, underside of this, then I'm going to polish on the finish stone. And that's not the last time I'm ever going to touch that, but that's my prep for the back of that. I don't do the ruler trick on there. I don't do a secondary bevel on that side, because if I do, that means at some point I'm going to have to regrind this thing. I don't want to do that. So I treat it like the back of a chisel. Then when I'm ready to sharpen this, there's not a whole lot of metal there. Not a lot of surface area. So I hit on the 1000 grit stone, and I just work till I've got a burr. You will find that you'll dig into your stones if you go forward with this one. I shouldn't have been going back and forth. I'll typically just work on the pull. As soon as I feel a burr there, I go over to the finished stone, polish that, and then at the very last, I'll do that drag along the edge. Yeah, well, I'll do this once, and then I would spin it or flatten it. I'm not going to just keep working. And then I'll hit the top, the back side. Yep.
When you were talking about, thickness and shape that you take, it's also depends on the material you're cutting too, right? You cut a very difficult material, like shaving pine with a blade as opposed to doing like hard maple.
What you're going to find is that once you have sharp tools, you take much thinner cuts, no matter what you're working with, because the blade is taking the cut that it can take. If you have a blade that's not optimally sharp, there's a little bit of a rounding at the tip. So you have to bring anywhere from 1 to 2 times the amount of blade out to get it to cut at all. And it'll it's not fully engaging, so it looks like a thin cut, but it's not really. It's biting in a little more. It's being a more violent cutting action than it should be. As soon as you get a really crisp, keen edge, then whatever blade you bring out for a depth of cut is what you're removing from the stock. So sharp tools, you will have less blade exposed to get heavier cuts. It may not sound logical, but it's the way that it works. So when you start working with really sharp tools, you're going to find that it's a lot harder to push those heavy cuts than because you're actually removing all that material. So you'll naturally back off.
So what I'm saying is, my experience as I started working with, say if I'm working a piece of pine that's simple, cuts really easy, then I go to something that's a lot more difficult, right? And you go to take, say, a certain thickness and cut like that, right? I mean, it's going to be a lot more difficult than wood. So the plane tells me you need to back off.
Right.
You take too much, right?
Yeah, absolutely.
That's what
You can get away with stuff,
I can do it, but I mean,
but the sharper the blade is, the more you can get away with. So it all dictates. I mean, the tools will tell you what they will and won't do. And so if they're dull, it's like screaming through a brick wall. If they're sharp, it's somebody screaming right in your ear. You get much more. It's much more responsive. Yeah, it's a joy. Yeah. Why would we? What we do is we make the best possible tools that we can, and we price them fairly. So we don't discount, because we can't afford to discount. We don't mark things up to then afford a discount once in a while. We just price things fairly for what it costs to make them. And then the price is the price. When it comes to stuff like the frogs, we do that for our tools because they should be there. But we're not going to make something. Like for a while, we made replacement blades for old Stanley tools. They were 95 thousandths thick rather than the 140 to 200 thousandths thick that we make our blades. You buy one of those blades, doesn't fit in your tool. Now you're pissed at us because the replacement blade that you bought for your 85-year-old Stanley plane doesn't fit, doesn't work. It wasn't made for that plane. It was made to maybe fit, but you're still expecting it to fit. We can't make a frog that we know is going to fit, because every year that Stanley existed, they changed everything they did, and they changed it for the worse. If you look at their tools from 1890 through to 1970, every year there was some alteration, and it was never for the better. They were always removing something, taking something away, trying to increase their profit margin. So they stopped making the Stanley Bedrock system in the 30s because they weren't making enough money off it. It's a better way to set up a plane, but that didn't matter. Yeah.
There was a particular part that you wanted to fabricate that you like the
No, we don't do custom work. We've got to make these. We can't stop and make something for you. And even if we could, you would never pay us what we'd have to charge you to do that. I mean, we're not a custom fabrication shop. Up until about 4 years ago, 3 really, we've been making benches for over 10 years now. And up till about 3 years ago, every bench we made was a custom bench. And we were selling them from between $1,800 to $2,500 a piece. That bench, if you commissioned somebody to make it for you, would be probably $5,000 to $6,000. So we basically, it was costing us money to make benches for the first 10 years that we made benches. We standardized what we do now. So we make 2 sizes. We'll make it any height you want, but it's 24 inches wide, it's 4 inches thick, it can be right-handed or left-handed, it can be any height you want it, but that's it. That's your options. We used to do whatever somebody asked, and we can't do that. You know, it's similar to the 01 blades. It takes us, or the Stanley replacement blades. It takes us twice as long to make those blades. Because we're using the same stock, but we've got to grind twice as much material off. So that's every 100 of those that we make is 200 of our own blades we can't make because we're using the same equipment to do it. So we're not a fabrication shop. We're a production shop. We're not a mass production shop. Yeah.
When you have the blade set, how far below the plane of the sole does it penetrate?
Depends on how sharp it is. If it's sharp, if it's a keen, sharp edge, as much blade as you have exposed is how much is embedded in the wood. If it's a dull edge, if it's rounded off, it only penetrates some of the distance that you have out. Well, like I said, there's 3 cuts: roughing, flattening, or finishing. Roughing cuts going to be between 4 to 10 thousandths typically. You might be really aggressive and take more. Flattening cuts are going to be about half the roughing cuts, so between 2 to 4 thousandths. The finishing cuts, or the thinnest cuts you're going to ever take, those are going to be between 1 to 2 thousandths. And if you're taking less than 2 thousandths of an inch for a cut, and you got the blade set parallel to the sole of the plane, then the corners won't dig in. So you don't have to camber the blade. Who's asking about cambering? So cambering is the action of introducing a curve or a radius on the blade. And I firmly believe that the reason that people used cambered blades in the past is that they couldn't flatten their stones. It has become such a ingrained part of how people work that there's no real documentation of how it started, but it's just what people have always done. But the one thing that you can't get from a stone that isn't flat is a straight line. So if you know your stones aren't flat, you can introduce any curve that you want to that blade, but you can't get it straight. So if I know I can flatten my stones, then I can sharpen with a straight line on the blade. If you're going to be regularly taking your final thickness passes at greater than 2 thousandths of an inch, you should camber the blade. But the camber or curve only needs to be an amount that buries the corners of the blade and allows the thickness of shaving that you want to take to happen in the center of the blade. So if I'm cambering my smoothing plane, I'm going to do the same process that I did here. And at the very end, I'll stack my fingers on one corner and do 5 or 6 extra strokes. Stack my fingers on the other corner, do an extra 5 or 6 strokes. So I don't have an actual radius on that blade. I've got a straight that feathers down, and it's only going to drop off at the corners by about 3/1000ths of an inch, because I'm never going to take more than 2/1000ths with it. So that's how I would dress those. For something like my jack plane, if I want to use this for heavy removal, I'm going to put an 8 to 10 inch radius on that blade, a true arc, a true curve. So I'll actually draw that curve on and just work through a curve until I've dropped that off. It's usually about a 1/16 of an inch drop to the 2 corners. This joiner plane, if I want to camber it, that's one I almost never would camber. I'm going to have about half of the radius that I would put on the jack plane. So it's like a 12 to 16 inch radius. So it's still not, it's only needs, if the heaviest cut you're going to take is 4/1000ths of an inch, you don't need more than 5/1000ths drop at the corners. The more arc you put on, the less of that blade you use at thin cuts. So you don't put a 10 inch radius on a smoothing plane blade for a camber. You're putting a 3/1000 drop on the corners.
I noticed on the slope of your plane, it has grooves on it. What are those grooves for? The one you just picked up?
That's so you want to buy it. In really pitchy woods, it's helpful to have a little less surface area there because it doesn't stick as much. But other than that, it's really not, this is, the grooves don't run out to the ends. So the surface tension is the same whether the grooves are there or not. You're not minimizing the suction down to a flat board by having those grooves in there. The real benefit of this is that when you had to flatten an old gray iron plane base, there's a hell of a lot less material to remove. That's the real benefit. But the idea that it somehow reduced the drag, it's no. If those grooves went all the way out through to the ends, so you had an air passage, then yes, it would reduce friction a little bit. But the way they're done, that's not what it's doing. So the mouth opening, the throat is the slot in the body of the tool. The mouth is the gap between the front of the throat and the tip of the blade. So you control the mouth opening on a block plane by moving the adjustable plate in the front. Same thing on these low angle jack planes. You loosen the front knob, you move the front plate, you can adjust and control that mouth opening. With what's called the bedrock system, you don't have to take the blade out or the cap iron off. You just loosen 2 screws on the outside here, and then the center screw turns and you can move the frog forward or backward. The throat opening, or mouth opening rather, wants to be as tight as you can get it and let the shaving you're going to pass through or pass through. So it depends on how heavy a cut you're going to take, how tight you might want to make that mouth. I typically set, like I said, I'm setting my tools up for the cuts I want them to do before I use them. I'm using my jack almost exclusively for roughing. I'm using my joiner for flattening. I'm using my smoother for finishing. So I'll set this one for as tight a mouth as I can get. I'm usually, if I had to measure it, it'd probably be 4 or 5 thou, maybe 10 if I was going back a little bit. The joiner plane, I'm going to have a little more open because I'm taking a little bit heavier cuts. The roughing plane, that's going to be as open as I can get away with. What that mouth opening represents is potential lift. So when you go against the grain and you catch the fibers, they want to lift up. The toe of the plane, the front section of the plane, is going to stop those fibers from lifting. So if it's right where the cut is happening, they don't lift up and break. You're more likely to get a clean cut. It's far more important that you have a sharp blade, that you're taking a thin cut, and that you have the appropriate effective cutting angle coming into the stock. Those are more important than the mouth opening itself.
Question about the chip breaker and a blade. How far should, what's the protrusion that you would, I mean, you know, I know what I said.
It depends on if you're using it as a chip breaker or if you're using it as a dampening plate. Its intent was as a dampening plate to minimize vibration. If you stay within a 16th to a 32nd of an inch away from the cutting edge, heavier cuts, you want to be a little bit further back. I'm typically about a 32nd of an inch back.
So in other words, the closer you have it, with the close cut, you're just going to jam the shape come through.
Right. So
that's why you want to bring it back.
You get into your question of does anybody analyze angles and all this. A couple of years ago, there was a thing going around on the internet about a study done in Japan about chip breakers and how they function. And if you bring the chip breaker right up to within 3 or 4 thousandths of an inch of the cutting edge, then as the chip comes up, it strikes the chip breaker and breaks clean rather than separating and going anywhere. Setting your planes up that way is unbelievably finicky. So I would rather put a higher angle of attack coming in, either by changing the frog or honing a steeper back bevel angle on the blade so that you don't have two pieces coming together. You've got a solid constant that the shaving is striking against to break 3, just less hassle for setting up. So I typically am about a 32nd of an inch back from the cutting edge.
Set those planes down, the blades down.
Yep, you were probably beaten into putting them on their sides.
Some people would not do that. Some people have a sticker across and they can set the toe on.
That's fine. What was this made to do? What's it sitting on? In this particular case, it's also sitting on some nails and some other stuff. My bench at home does not have nails bedded in it. I keep it clean. As I said to somebody, if your bench has a bunch of nails bedded in it, burn it. You know, I mean, this to me is an easier way to work with my tools, and it protects them more. When they're sitting on their sides, if you set it down too hard, you're going to skew the blade. It's harder to pick up afterwards. You might cut yourself, but worse, you might damage that blade with another tool. Now you got to go back and sharpen. Who wants to do that? You might scratch or dent the sole of the plane with it sitting up on its edge. Putting them down makes them easier to work with. It actually protects things. You can always put a little strip down if you're really worried about what might be there. Most of the time, my bench is covered with shavings, so I'm not gonna cut my bench top anyway. You know. So, in case you can't tell, I've never answered that question before. Well, it's a non-question as far as I'm concerned. You can do whatever you want in your own shop. I'm not going to come take your tools away because you put them down on their side. But the thing that bothers me about that whole question is, for 99% of the people that ask that question, if I ask them back, why do you put your planes on their side? Their one answer is, I was told to do it that way. I can come up with 15 different reasons why I put my planes down this way. If you can come up with one reason, which is I was told to do it that way, then I'm not going to follow you. You know? Yeah. Well, but again, my blades are so, there's so little blade exposed that I'm not going to cut the bench anyway. So it's, but again, I don't care how you do it. Most people, their habit is to put them on their sides because that's what they were taught. That's what they were trained to do. It's really hard to break a habit like that. And there's no reason to break it unless something goes wrong.
I asked a question a little earlier. I said my shop teacher told me that in high school. He said that's because he was responsible for the blades.
Yeah, it's the truth. And every kid in your class was going to have the blade sticking out about 1/8 of an inch. They were going to be banging it across things. They're gouging up the bench tops. That's why people were told to put their planes on their sides. Yeah.
In regards to the I recommend, that was always an issue. I know the higher end, like your fits, 5-degree pitch, more difficult frames. Like they're all along frog. What would you recommend? Say like for a flat thing, stay with the standard frog and the higher end.
It depends on which plane you're using. If you use the number 8, which is the one I tend to use, we don't make the higher angle frogs for that. Partly because it's the only tool that we make that has a 2 5/8 blade, so it doesn't have that frog is dedicated only to that one tool. But also because the mass of the number 8 means that the times when you feel a need for that higher angle are much fewer. If I were going to have angles appropriate to the types of cut I was going to be taking, I would have my jack set up with a 45 degree, I'd have my joiner set up with a 50 degree, and I'd have my smoother set up with a 55. But, like I said, the 8, which is the one I typically use, because I find the heavier a plane is, the easier it is to work with. Because that when you're talking about the difference between a low angle and a traditional angle plane, the low angle is the angle of the bedding point for the blade. So with a low angle tool, as soon as you push that forward, there's an immediate transfer of energy into the cut. With the higher standard angled tools, there's more resistance. So more mass with this type of plane means it's easier to push through the wood. With this one, the lower angle of attack means that it's going to feel like a heavier tool of the same size. So if I have the 5.5 and the 62 set up for the same thickness cut, they're going to feel very similar moving through the wood. If I do the same thing with a number 5 and the 62 is going to feel nicer going through the wood because there's that energy transfer. When it comes to the actual results in the material, it's dependent on how much grain figure there is, how many changes of direction there are, how hard is the material you're working with. The harder the material and the more figure there is, the steeper the angles want to be. The softer the material and the straighter the grain, the lower angles you would want. If you're working in end grain, the lower angle gives a cleaner cut. The higher angle tends to pull the fibers a little bit. In really soft woods, the lower angle slices through the material a little bit more easily. The higher angle tends to pull the fibers a little bit. In the harder woods, you'll find that the lower angle blades tend to skip out of the cut. You have to bring a little more blade out to get it to bite in, and then it's harder to push anyway. The higher angles engage more readily in the harder woods, so you can take thinner cuts and still get effective cutting. So that kind of stuff is where you're starting to rely on experience and how these wood things have behaved in the material over time. If your blades are sharp and you take thin cuts, you can get away with almost anything. So when you start getting to the point of wanting to have varying angles, you're starting to get into the sort of upper echelon of the craft. If you're just getting started and just trying to get shavings in a piece of wood, this is where you want to focus all your attention. Don't worry about the mouth opening. Don't worry about anything else, because as soon as you start getting good sharp edges, you're automatically going to start backing the cuts off. You're not going to be taking as heavy of a cut anymore. As soon as you start taking a lesser cut with a sharper blade, all of a sudden tear out goes away. There's like 1% of the wood you work with has tear out problems rather than 70% of the wood that you work with having tear out problems. Grain direction doesn't start to matter as much. You start noticing milkiness in the surface rather than tear out. So you plane one direction with a 45-degree frog, and you get a little bit of a milky surface. You plane the other direction, you get a glassy, smooth surface. You plane that same poor direction with a higher angle, you might find you get a cleaner finished surface because you're going against the grain, but you're shearing across the fibers with the higher angle. But again, those are things you won't even start seeing those subtleties until you've dealt with the first level of it. Depends on which type of plane you're talking about. If you're talking about the traditional planes with a frog, the bevel faces down. A better way to think about it in terms of how to determine whether you're talking about bedding angles or sharpened angles, is it a bevel down or a bevel up plane? If it's a bevel down plane, it's going to have a frog, and it's presenting at 45, 50, or 55 degrees. And that change in the angle is what's changing the angle of cut. In the bevel, 35. Right, exactly. That's all it's going to do for you in that regard. On the Bevel Up tools, you've got a constant bedding angle. The blade is embedded directly on the body of the tool, and the bevel faces up. So if I've got a 12-degree bedded angle, and I sharpen the blade at 35 degrees, I've got a 47-degree effective cut. If I sharpen the blade at 50 degrees, I've got a 62-degree effective cut.
You can have the same effective cut on both a high angle and a low angle plane.
Exactly.
That always confuses me. Why is one in favor over the other? Cutting angle.
Because you may prefer the feel of the tool in your hands, one to the other. If you're getting started in the craft, you may find that these low angle planes are a little more versatile, so you don't have to have as many tools. You can minimize the number of tools that you have. I don't have to make a lot of choices about which tools I have. So at home, I've got a 62 and I've got a 5.5. I use both of them regularly. I would recommend that to anybody that wants to have a broad scope of tools at their disposal. But if you can only have one of them, get the 62 and an extra blade. 2 extra blades. I'd get the blade as its own, as a roughing tool, and I'd have 1 extra blade. I'd keep one blade sharpened at 35 degrees, and I'd keep the other blade sharpened at 50. Absolutely.
You just got laid off today.
Actually, in all seriousness, we're always looking for good machinists. We're looking for people that want to produce a quality tool. You know, we need people that take pride in what they're doing and willing to live in a rural area in a somewhat obnoxious state. You would have to live with our governor, after all. You had a question?
Yeah.
Most brilliant marketing strategy ever devised. Not a thing. If there's a number 1 and there's a number 8, you must need all the ones in between, right? Like I said, Stanley was, every decision they ever made was about the bottom line. They actually made very little. The Stanley Rule and Level Company made very, very little. What they did was they found things that they liked and they bought those companies. They were like the Borg, if you ever watched Star Trek. They just assimilated everybody into what they did. So they were one of the largest companies in the U.S. in the 30s and 40s, and they still are a massive company. But they just basically, so their entire adjustment system is the Bailey adjustment system. Bailey had his own company. They made better tools than Stanley made. So Stanley came along and made him an offer he couldn't refuse, essentially. And then when he finally passed away, they released the Sweetheart series as sort of a tribute to him. I can't remember, Andrew Bailey? I can't remember his first name, but right. They just assimilated. Record, same thing. They absorbed records. So in the 70s, when Tom was working at Garrett Wade, the best quality Stanley planes you could get were the English-made record Stanley planes. So they had absorbed the record company as well.
What I want to say is, you only need 3 planes to really do it off a highlight.
Well, I hope that if nothing else comes across from what I've been talking about this afternoon, you understand that the key to success with anything is sharpening. If your tools aren't sharp, they don't work. After that, you need to understand what you're asking the tools to do and how to set them up to be able to do that. And then that there is a very specific grouping of tools that will work together to allow you to build things. And that's what we have here. Listed in our catalog, you'll see, I think it's the 3rd or 4th page in, we've got the core tools. So what I've got here are very specific, but you may have noticed, or maybe you didn't, when I was talking about them, I didn't say I had a 62, a number 8, a 4.5 bronze, a 73, a 71, a 60.5. I said I had a jack plane, a joiner plane, a smoother, a block plane, a router plane, a shoulder plane. I don't care which one you have. You need those types of tool to do the work that you're going to do when you're building a piece of furniture. Because each one of those is designed to do very specific things. You can clean up the shoulder or the cheek on a tenon relatively easily with a shoulder plane. But you get a perfect parallel step if you use a router plane. You can use a chisel to make a dado, a chisel and a saw to make a dado. If you have a router plane, you can make a perfectly depth dado. If you want to put some inlay in, you can step down to a specific depth and work around. If you don't have this tool, you can figure out other ways to do that job, but it's not as easy to do it. But I wouldn't try to cut a rabbit with my router plane. I'd cut a rabbit with the shoulder plane because it's got a longer bed, longer surface area. It's going to give me a truer, straighter line, and it's easier to do. So these two tools will both do very similar things, but they each do different elements of that in a better, more effective way. If I could only have one, it'd be the 102, because I love it. You can't have mine. I don't care who you are. I've got a fairly large hand. Somebody who's got a tiny little hand, you pick this thing up, you think it was made for your hand. It's just so comfortable. It's such a sweet little plane. We call it an apron plane, because it's something you'll carry around with you every day when you're in your shop, and you'll use it all the time. But there are some times when it's too small, and maybe you want to be able to control the mouth opening for some ungodly reason that I don't know. But the 60.5 is the more all-around versatile of the tools. If you want to have one that allows you to do all the stuff you do with the 102, all the stuff you do with the 60.5, and some of the stuff you do with a shoulder plane, get the 60.5 rabbet. Same footprint of a tool, but the blade goes all the way through. Doesn't have an adjustable mouth, so it would be more of sort of a carpenter's tool in the sense of you're on a job site, and you can carry one plane around instead of 3. Makes sense. But if you're at your bench at home, you've probably got a whole array of the tools that you use every day, the ones that you use all the time, right there at easy reach, easy access. I'd take the 102. Or maybe the 101, because that's even sweeter. But now then you start getting into the affliction of tools. But no, if I were just going on the go, then you can put that in your back pocket, and it's totally comfortable. I've probably babbled on too far.
You can stay here all day. I know you got some traveling to do, but
I would pity you for the rest of your life. Now, if you can only get one plane, get the 62, the low angle jack. But I would strongly encourage you to get the 62 and a block plane. And I'd probably get the 60.5 rabbeting block, because then you've got your block plane, you've got your shoulder plane. You can use it for doing rabbets. You can use it for multiple things. And I would get 2 chisels. I'd get a 1/2 inch and a 1/4 inch chisel. So that's 4 tools that will allow you to do a wide range of things. And if you can stretch yourself a little more, get a dovetail saw. That's the sort of core of the core. But what I would recommend, if you're starting out with this, try to there's three groupings of tools. You've got the bench planes, you've got the joinery and detail tools, and you've got the saws. If every time you're ready to get some more tools, you get something from each group, then very quickly you'll have the whole chunk together. And like I said, it's about $2,500 to $3,000 for the entire array of tools. If you're willing to go out and buy a table saw, or you're saving up to go buy a table saw, take that money and get all of the tools that you need to do the stuff by hand, because if you have just the table saw, you can't build stuff. What's that? Okay. Oh, sweet. eBay calls. The ruler trick? That's simply putting the ruler, this thin ruler, on one side of the stone, the finished stone, and you polish the very back of the blade, your plane irons, not chisels, and you're putting a little subtle back bevel on it. For almost all of the stuff I've been talking about, we have videos on our website that refer to them in some way. We've changed things a little bit over the years, but the basic message is very much the same. So if there's stuff that you're not really sure about right now, you can look there on our website and you'll find it. Go to our YouTube channel. There's an educational section. You'll see it says free instructional videos. And in there's a hyperlink to the YouTube channel. If you click on that, it sends you to the full array of all the videos we've got available. And I'm not trying to brush off your questions, but I probably can't answer them in a way that's going to stick right now. But you can go to that area and see it. But if you're looking for one plane to get started with, get the 62, add the tooth blade because it gives you a lot of versatility with it, and then start to add in other things where you can.
Okay, I want to thank Denab for a really great talk.